This example problem asks or says, an air column is being designed so that its second lowest resonant frequency is 440 hertz. The column is open at one end and closed at the other. What length should the column be if the speed of sound in air is 340 meters per second? All right, so this is open at one end and closed at the other. So our frequency equation for an open closed pipe is mv over 4L. And we're also told that m is 1, 3, 5, 7, and so forth. So here it's telling us the second lowest resonant frequency. The fundamental is the lowest. Mode 1. This would be the second lowest. So we're saying that m equals 3, because that's the second possible m value, is a frequency of 440 hertz. We're trying to find the length of this air column, and they've also told us to use a speed of sound of 340 meters per second. So looking back at our equation, we know the frequency, we know the m value, we know the speed, so the length is all we're looking for. So the length of this column, just bringing the frequency down, our m value is the second lowest m value is 3. That's, of course, since these m values can only be odd. The speed of sound, skipped my 340 meters per second. Our frequency, 440 hertz. So plugging this in, I'm getting 0.5795. Going back, the 440, 340, we've been assuming thus far that our numbers are accurate to the digits shown. That would be 3 sig figs. Of course, that is usually we put a decimal place at the end to mean 3 sig figs. So whether you wrote this as 0.58 meters or 0.580 meters, you would have the correct answer.